So, I'm Stéphane Landelle. Thanks a lot for coming to this talk, and thanks a lot to Vox Days for having me here. Yeah, my name is Stéphane Landelle. I come from France, and I'm here to talk to you about a load test tool that I started developing something like 4 years ago. It's named Gatling. Which one of you has already performed a load test here? Quite a few. Do you know what load testing is about? Pretty much. Yeah. So we'll go fast on this. When you run a load test, you want actually three things. You might be wanting to anticipate on problems that might happen on your production system, on your next version that's not live yet. You might also want to reproduce some issues that you experienced on your live system, but you didn't have you didn't have sufficient information in there to actually identify and fix the problem. So you want to reproduce it on a safe environment and try to figure out what happened and try to fix it. And there's also a very interesting, very important byproduct of running load tests is that you'll probably have to build a dedicated environment. So you'll have to find out how you can automate your deployments. You'll have to monitor your system in your load testing environment. And you will benefit from this to run your real live system. You'll learn how to tame the beast. But why should you care about load testing exactly? Quite often on big projects, I see that people don't run the load tests for several reasons. First, they usually think that they don't have the time. They've been developing like crazies for 6 months. They don't even know if they will be able to meet their deadline properly, so they try to squeeze things, and usually the load tests are just discarded. Also, some people think that that's a complex issue, complex matter, so they think that they don't have the skills. They would have to hire somebody outside, have some consulting. So that scares them a little bit, but actually, as I said, that's really something that will help you tame the beast. You have the developers, you have the ops people that will have to operate the system on your live platform. So honestly, you have the skills. You are the one who have the skills. And also sometimes people think that, well, what bad things could really happen? You could damage your business pretty badly with poor performance. If you're an e-commerce website, you could have poor conversion rates. Maybe that your application is not properly developed, so maybe you need a huge cluster while you just would need just a few machines or even a single one to actually run your application if it was properly developed. And I even saw strikes because of applications that really made their users' life and daily job a misery. I know I'm French and that we are world renowned for going on strike, but this didn't happen in public transportation. This happened in a bank. I've never seen people in a bank going on strike, but this really happened because the application that they had to use on a daily basis really performed poorly. So what do you need so you can run a load test? Before tools, the first thing that you need is people. People with different skills. Okay, you will need QA, people who are familiar with running load tests, but you will need your developers on board because they are the ones who developed the application, and sometimes they already know that they're not very confident about how the application do some specific things. So they have some knowledge about what could break in their application. You will need DBAs because quite often the performance issues come either from the database or the usage that's been done of it by the application. You will need your ops people because you might have issues on your system, you might have issues on your network, and you will need them to monitor your system so you get you're able to find out where your issues actually lay. You will probably need some help from your business analyst, because they are the ones who know what kind of load to expect on your application. What's the daily standard load, what they would expect from a business point of view as soon as the brand new commercial air on prime time. So we only need the help from the business people too. And then you will need tools. So you will need some monitoring, so you can gather some metrics from all over your system and gather them inside the dashboard, so you can dig and find out where your issues actually are. Load testing is not just about hammering your system and see if it crashes or not. It's about finding bugs and fixing them. Otherwise, it's just nonsense. And then you will need the load test tool, which is also named an injector. So what's a load test tool exactly? It's a tool that you use to simulate a bunch of users on typically a website. Those tools are typically protocol clients. They are not browsers, because running such a bunch of users, like such a bunch of browsers, such as thousands of them, is very expensive in terms of CPU and in terms of memory. So all those tools actually work on protocol level, such as HTTP. Okay, so those tools typically won't execute your JavaScript. They won't load your CSS and then download like the background images that match something in your DOM. So if you have really complex logic in your JavaScript, you might have to re-implement it in your load test scripts. That also means that honestly, some technologies are more complicated to load test, where typically technologies where the view logic is not really decoupled from the business logic on the server side. Like if in your payloads you have tons of view IDs and dynamic components IDs, etc. It's more complicated to test. And also, in this talk, I will only focus on tools that let you implement rich behaviors, like really complex navigation inside your application. Not just tools that I call URL bashers, like tools like Apache Benchmark or Siege or WRK. Those tools just hammer a given URL over and over again. Everything is static. Those tools are very efficient for this, but in my opinion, they are more convenient. They are more suited to test HTTP stacks than real-world applications. So I decided to create. Why did I decide to create my own load test tool? Because there are so many of them available, both open source and both commercial products. The most famous load test tool on the JVM is JMeter. It's been out for something like more than 10 years. And probably the most famous commercial product is LoadRunner. It's quite a good tool, and it's very, 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 very expensive. So in the next part, I will explain you why I wanted to build my own tool. You've maybe heard the saying, when you start an open source project, yeah, congrats, because now you now have 2 full-time jobs, and one you don't get paid for. So that was something that I really had to consider before studying it. So the first thing is that when I started Gatling 4 years ago, I wasn't very satisfied with the performance of the load test tool that I could get as open source. The first thing is that most of the tools were implemented, they implemented the virtual users as dedicated threads, okay, for the ones running on JVM. So, but you're Java developers, and you know that when you run something like 50 threads on a JVM, on an 8-core machine, your application will be super fast. You need those threads to run things concurrently anyway. But if you implement virtual users as threads, and you want to run 2,000 virtual users, you will end up with 2,000 threads. And think about what happens when you want 10,000 threads. And this model doesn't scale, because you're not supposed to use threads this way. It's just like a juggler that has to juggle with 2,000 balls. It's too much. You have a lot of context switching, use a lot of CPU just to schedule the threads on the different cores. So that's not how you're supposed to develop concurrent application nowadays. It was a convenient model 10 years ago, but we now know better. Also, most of those tools were, at this point, using blocking IOs. Some still do. It means that when your thread send a request over the wire, it actually waits for the response. So if you start having a look at what your thread actually does, you'll see that they spend quite a lot of time waiting, and all the more when your response time is high. And things are actually even worse because with your virtual users, you want to implement real user behavior, and real users don't send a new request every millisecond. What they do is that they get a page, they take some time to read it and decide on the next action that they want to perform. And how do you implement that in Java with a thread? Sleep. So if you have a look at really the occupancy of your threads and how they work, your 10,000 threads spend most of their time doing actually nothing. So I wanted to come up with a better architecture. So for Gatling, I went with the actor model implemented in AK. So basically, Gatling is message-oriented. In Gatling, the virtual users are not threads. They are just messages that are passed, that are put inside a workflow. And the threads are just technical resources that move your virtual users from one step to another into this workflow, like send in a request, do a pause, do a loop, etc. All those are steps, and virtual users just go from one step to another. And threads are just the technical resources that push them from one step to another. Okay. So typically with Gatling, on an 8-core machine, you will run something like 40 threads top. Okay. Also, we don't, of course, use blocking IOs. We use non-blocking IOs. Actually, we have the primitive in Java to perform non-blocking IOs since JDK5, but it took quite some time to get the implementation stable and less buggy. And what we use is the Java framework named Netty. It's really well known. It's being used massively by Apple, by Twitter. It's the #1 NIO framework on a JVM. It's really, really good. And with Gatling, you can produce quite a high load. So once again, Gatling is not intended to compete with URL bashers and typically tools such as WRK. We are really optimized for throughputs and very, very high throughputs by just sending the same static request over and over again. Gatling is much more high level. There's tons of dynamic features, etc. So all this comes with another head, and we also run on JVM. But still, with Gatling, you're able to achieve quite a good throughput. This is what I could do on this machine, which is an 8-core with an i5 CPU. And I can, here you can see like I had something like, I could produce something like 50,000 requests per second on small payloads. And so you can get quite a good throughput with Gatling. Then the next thing, after performance, that I had an issue about with other load test tool was usage. Almost all those tools came with a graphical user interface. And maybe that's convenient for somebody who's not a developer, but as a developer, I didn't really find it convenient. One other thing also was that I wanted to perform load tests. I wanted to plug load tests on my continuous integration. I wanted to be able to version my load test and deal with my load test sources just like my application sources. So I wanted to be able to put them into my version control system and do versions and do diffs and have my colleagues review my work and share with them. And that's not something that you can actually do with when you only have a graphical user interface. Even if graphical user interface gives you something like a saving format, like a huge dump of XML. Honestly, it's not really convenient to handle this as real sources. Try to deal with a git merge conflict on a huge dump of XML. You'll have your tags broken everywhere. It's not very convenient for this. So what I really wanted to do was I wanted to have real code. I'm a developer, so I wanted a nice API that I could wear and have real code for two reasons. Because as developer, you usually have some patterns in your code, and you want to refactor things, and you want to reorganize, and you want things to be dry and reuse some components. So that's more convenient to do that with code. And also, even if you use a super great cool tool that has many features, quite often you have something very specific in your application that's not built in the tool, and you have to implement it yourself. And it's much more convenient to do that if your scenarios are actual code than just copy paste some groovy code into a text box, into a graphical user interface. Here you can directly code and directly hack into your scenarios. So this is what the Gatling very simple scenario look like. So it's a class. And you can see that you have a scenario. We provide a nice DSL, so you don't have to be a super rock star to be able to implement Gatling scenarios. You have a scenario here that executes one single GET request. We validate that the response status is 200. And at the end, we say that we want to inject into this scenario one single user. Okay? And I think that's it's for the people who've seen a Gatling scenario for the first time, it's quite easy to understand. So, sure, your scenarios are implemented in Scala. Don't be scared. Scala is not that complicated. It's actually you can do many things in Scala just like you would do in Java. The syntax is quite similar. And if you have a question, just have a look at the documentation. It's not complicated. Not that complicated. And sure, it has functions. It's both an object-oriented and a function-oriented programming. But now, since Java 8, you have functions in Java too. You have lambdas, etc. So those are similar concepts. The next thing is about what kind of metrics does the tool actually provide you with. You will want to measure your response times, but you don't want just to gather all the response times or the thousands and thousands of requests that you will send and just compute the statistics out of them yourself. You want the tool to generate them for you. So you have to figure out which kind of metric you would want to have a look at, because you want to consolidate all this data. Most of the tools provide you the minimum, the maximum, and the average value. What can you actually do with that? Actually, you can make any conclusion based on only those values. Have a look at this distribution. You have half your users that experience very good response time, and half of your users that experience poor response time. But the average value is just somewhere in the middle. So if you just have a look at the average value, you can make the conclusion that, okay, globally we're fine. Okay, we're done. And then you don't understand why some users complain. So just using the mean value is actually it's useless. So some people say, okay, I've studied maths, and I know that I also can get another metric named standard deviation that basically tell me how widespread the values are on the sides of the average value. Okay? Are you all familiar with standard deviation? Guess what? This metric is a crap too. Why? First, because standard deviation is only meaningful for normal distributions. And guess what? real-life distributions on IT systems are never normal distributions. Never. Have a look at all those data sets. They have the same mean and the same standard deviation. Do they look the same? Absolutely not. So if you have tools that only provide you with mean, max, average, and standard deviation, their results are honestly pretty useless. You need to have access to the real distribution and find out what your actual distribution look like. So what you should have a look at are percentiles. Are you familiar with percentiles? So it's a kind of threshold. It means that a percentile is the value behind which are some given percentage of all your values. You can see in this sample, so here is the 25th percentile, which is 7, because 25% of all your values are below 7. The 50th percentile, also named the median, it's where half of your, it's the limit, the upper limit of half of your values, etc. So you really want to have a look at all those percentiles so you can have a good idea on how your values are distributed and how good you are and how bad you can be. Because that's also, you're not interested only on knowing how bad you can be, but also how bad you can be and where you want to fix things. You have to be aware about how your percentiles are computed. Some tools that provide you percentiles actually lie to you. Like there are some tools that actually reverse compute the percentiles from the mean and the standard deviation because they assume that you have a normal distribution. So they make the assumption that you have a normal distribution and say, okay, easy, the 50th percentile is there. It's the standard where you have the standard deviation, etc. But this is completely meaningless. They're just lying to you. Another bad implementation is that you can do some sampling on your values. Like, let's say that you want to measure every second your percentiles. Okay, so you're supposed to gather all the data on a given 1 second, and then sort all the data and seek for the limits. But some tools are actually implemented as bounded queues. So for example, they only retain 200 values, the last 200 values on a given second. So actually, you're missing all the first requests on a given second. So if you are performing something like 1,000 requests per second, and that your maximum sliding window size is 200, you're just discarding the first 800 values. And if your hiccups were in this time, at this time, you just don't see them. Another issue with percentile is that if you just store into your system the final percentiles, like every second you measure the percentiles for each request, and then you push all this data into something like Graphite or InfluxDB or whatever, and then you want to say, okay, now I have the percentiles for every request, and I want the overall percentile on this given second. Or I want the percentile for all the requests on a very long time window, not only just 1 second. How do you think those tools will compute those percentiles? They just give you an average value. But it's just nonsense. It's just like you're telling me that you have some maximums, and you want to find the maximum of the maximums, and you're telling me that you're performing an average. This is wrong. You want the maximum of the maximums. And the same thing goes with percentiles. You can't average percentiles. So you have to be aware about how percentiles measurements are implemented, even in those tools that provide you such metrics. If you live in the Java world, there's two very good percentile computing implementations the first one is AGR histogram, and the second one is tdigest. They both have their pros and cons. AGR histogram use more memory, but is really, really fast. And tdigest use way less memory, but it's way slower. But yeah, you really have to check that if you run on JVM, you have to check that if you measure percentiles, that you use one of those two implementations. As far as I know, other implementations are wrong. With Gatling also, I wanted to be able to integrate load testing into my development environment and into my continuous integration platform. So with Gatling, we'll support several protocols, HTTP, but also more complex things like WebSockets, server-sent events, polling, GMS. We have a Maven plugin, a Maven archetype, an SBT plugin. We also have a Jenkins plugin, so you can plug into your continuous integration. So all those are the official plugins that you can get directly from the Gatling project. But you can also find some third parties plugins, typically on GitHub. There is a Gradle plugin, there's some Cassandra support, some AMQP, etc. There's quite a few plugins. So you can implement your own protocol support with Gatling. Let's try to do a demo. So I know it is pretty dangerous, but it's quite fun. So I wanted to show you that how you can use Gatling inside your development environment. So what we'll be using it here is Eclipse. You can also use IntelliJ. You can also directly use whatever text editor you want, or Vim, or whatever. So this is Eclipse with some Maven support plugin, and also the Scala ID, which is the Scala plugin. If you use IntelliJ, you only need to install the Scala plugin. And it comes for free in the community edition. I'm going to create a new Maven project based on our archetype. So I get something very similar to a regular Java Maven project. So I'm going to select my archetype. Yeah, and generate a project. Let's call it fast. And here you see that I have a very familiar folder hierarchy with my sources. Main difference with a regular Java projects is that I have a Scala directory instead of having a Java one. Gatling also comes in the form you can also we also provide a bundle distribution with all the libraries and the scripts to launch Gatling. So you don't actually need an IDE to develop your Gatling your Gatling scenarios. You can just pick up a text editor with some Scala syntactic coloration, and it's pretty sufficient. Here you have some launchers. So I showed you an example of what a Gatling scenario look like. I told you that you can. There's an API, so you can code, etc. But we don't force you to directly code from scratch. We also provide you with a tool that we call a recorder. So the recorder has actually two flavors. The first one is that you can configure it as a proxy on your browser, and it will act as a man in the middle. It will capture your HTTP traffic and will generate a simulation, a scenario for you. Okay. There's also a second mode, a second flavor. You can feed it with an HAR file. HAR is it's an export format that's supported by Google Chrome Developer Tool, and there's also a plugin for Firebug for it if you use Firefox. So basically, it's a file that captures your navigation and all your HTTP requests directly from your browser and export it into a JSON format. So you can just import this JSON file into the recorder, and it will generate a scenario for you based on this. with the Gatling syntax. I'm going to demo you the proxy mode. So I'm just going to start my, this class is just a main class. And I have a simple graphical user interface. And here I've selected the proxy mode instead of the HR converter. I'm going to say that, so you see that here I will have a proxy that will listen to the, on the 8000 port. I'm going to say that I want to filter out every static resources. You can, because I consider that, well, for this demo, I'm not interested in how images are loaded. Sometimes, well, usually you'll probably serve your static content from a CDN or from whatever cache. And except from a network point of view, that's not where your bottleneck will probably lie. So let's go. Yeah, just to show you, so for this demo, I'm going to use the computer database. It was assembled, shipped with the Play framework until a few versions. Now they removed it. It's just a basic CRUD application with a list-on computer that you can search in and that you can browse and where you can edit and create new computers. Just basic CRUD. Okay. So now I have my proxy running on the 8000 port. So I'm going to configure it on Firefox. Here it is. Yeah, sorry, it's in French. So yeah, I have configured my proxy here. So if, sorry. Let's go to the home page. Yeah, you can see here that there's been some requests that have been recorded. There was a first GET request that returned a redirect, and then my actual page, my actual landing page. So, I'm going to show you how we can capture, let's say, business processes. So in order to be able to find out where I am in the file that I will generate, I will just enter some tags that will generate some comments into the generated code so I can know where I am. So at first I'm going to capture a search process. So I'm going to enter MacBook and search for MacBook Pro and select it. Okay? Now I'm going to browse into the catalog. Going back to the home page, and I'm just going from one page to another. And finally, I'm going to show you how I can do some computer edition. Let's add a new computer. Select the company. Yeah, I can. Why not? And here I am. So now I'm done. I'm clicking on Stop and Save. And if I have a look into my ID, yeah, and I have my simulation. So it's very similar to the sample that I showed you previously. So this is what a Gatling scenario, Gatling, what we call simulation, look like. So it's a Scala class. It's very similar to what you can see in Java. You have a package, then you have some imports. You have a class that extends some abstract class. Then what you have here is what we call the protocol. It's where you can place some common configuration that will be used by all the requests inside your scenario. So like the base URL, so it will be used as a prefix for all relative URLs that you have in your scenario. So for example, you can switch from one environment to another easily. You don't have to change all your requests. You have all the common HTTP headers that will be added to every request. And you can add tons of common configuration in there. Then this is your actual scenario. So you can see that I had some requests, some poses, some other requests, etc. Here you can see a request with some query parameters. You can see also that Gatling capture the actual post times that you made. And those post times are very important because this think time is what will drive the number of requests per second that your load test will be sending. So it can be interesting to give the recorder to real user, so they can use the application as they used to. Because as developers, sometimes we really don't know how the application is actually used, and sometimes real users go very, very fast on some use cases, and some use cases take them more time. So yeah, feel free to hand the recorder over to real users. And then you can see at the end, here's my form that I've posted. Okay. And at the end, you can see the setup. So here I configure the HTTP protocol. I attach it to my setup. And I say that I inject only one single user. What I want to show you here is how interesting it could be to have a real programming language, how you can reorganize things. Typically, you will have multiple scenarios, and there are some common processes into each scenario. You don't want to have to duplicate and copy-paste all of them. You want to be able to take them out and reuse them and recombine them, recompose the way you want. So I'm going to show you how we can extract some process parts and recombine them, do some composition. There's many ways to do that. One of the ways is to use what's called in Scala objects. Scala has native support for singleton objects, so for singletons. Those are objects. Okay, so it's just a singleton. So I'm going to create a search object where I'm going to extract the request related to the search process. So I'm just moving things around here. I'm not changing anything yet. The second process is browse. Oops. Yeah, just moving things around. And the last one is edit. For those who are not familiar with Scala, val means that it's a non-reassignable reference. It's like having something final in Java. And you also see that I don't have to declare the type of my references because Scala can infer them. So Scala is very, very convenient to write DSLs. So now I end up with an empty scenario. So I'm just attaching back all my pieces all together. Just like for actions, I just use the exec keyword. And so the first one was search, then browse, and edit. Okay? So now I could perfectly write other scenarios and recompose all those parts the way I want. For example, I can say that in my simulation, I don't have only one single kind of user with one single behavior. For example, I can have administrators that can perform all those actions, but then I have regular users who can't edit. So I can just remove this. And then I can say, okay, I have some admins. I also have some users. And I can reuse and recombine really the way I want. I can also, instead of just injecting one single user, which is interesting just to validate that your simulation is right, let's add some more users. So for example, I can say that I want to RAM some users over a given period of time. like 10 seconds. And I'm going to add 1,000 users instead. So we have tons of different injection models. Like instead, if you don't want to reason in terms of number of users, you can also reason in terms of arrival rate, meaning number of new users per second that arrive on your system. Yeah, so this is how you can do composition with and reuse parts with Gatling. Then what I want to show you here is that how you have to make things dynamic. If you just, here you can see that I'm injecting more than 1,000 users, but all of them will actually perform the exact same request and same actions, etc. And if you do that, there's a very, very good chance that you're not actually load testing your application, but that you're load testing your caches. They can be the cache, your web caches like Memcache or something like this. They can be the caches inside your database. Also, if you run, or the caches inside your application. Also, if you run a Java application, you have the just-in-time compiler that will optimize your code and discard everything that's not in the one single path that you have in your that actually get executed in your code. So that's not what you should be doing. You should customize every virtual user so that they can play different data and they can go from one path to another. So yeah, the first thing also that I want to do is that give proper names to the request because that's the name that will be that you will be able to read in the reports that are generated after running the simulation. So home. Here's my actual search, and this is when I select an element. I'm going to reduce the think time to 2 seconds for the sake of the demo. So now I want to make things dynamic. How can I make things dynamic? The first solution is I can create typically a CSV file and feed data from this CSV file into my virtual users. So what I want to do is that I want to create an extra step inside my simulation. That means every time a virtual user reaches this step, it will take a record from my CSV file and get some new session attributes. Just like you do with the HTTP session, you will just store some data inside a map. Sorry, the keywords for this is feed, and I say that I want a CSV file that I'll name search.csv. So I'm going to create this file. And I'm going to cheat. I'm going to copy paste. Sorry. So it's just a regular CSV file with the first line is headers that will be used as the names of the attributes that will be populated. So the default strategy is to have a queue, meaning that every time a virtual user reach this step, it will consume one entry in the CSV file. Here, I just have 2 entries, and I have many, many users, so I can use a different strategy. For example, I can say that I want to pick a random entry. And now that I have that, I can reuse those attributes that have been, this data that has been injected into my virtual users. So I can, for example, use Gatling's expression language. It's quite similar to what you have in JSTL. So here, this request was static, now it's dynamic. The next thing here is that, okay, now all my users do some dynamic search, but still they keep on selecting the same computer with the same ID. That's not what I want. One solution could be to add this link into my feeder, but that's a bit dangerous because you're already bound to your implementation. A better solution would be to capture this data inside the response of this to this request, so we can reuse it. So the API in Gatling to capture some data is the same that we use to validate. So here I'm saying that I want to perform some check that will capture some data. So you could, for example, use regular expressions and then save the captured data into a new session attribute. Here I'm dealing with HTML, and regular expressions are not very convenient for this. So I'm going to use a CSS selector, just like you would do with CSS. And I say that I want the link that contains the MacBook text, okay? And I don't want the DOM node. What I actually want is the value of the href attribute. And I'm going to save this as URL. Here I am. And then I can reuse it as it's a new attribute, just like this, okay? Let's go with the browse process. You can see that the browse process, it's not very dry. It's the same request over and over again, but just with an incremental counter. How can I do that? I just want to repeat something, actually. So I'm going to use our DSL element named repeat. I say I want to repeat 5 times. And let's repeat that. Sorry, here I'm repeating 5 times the same request over and over again. That's not exactly what I want. What I want is that I want to actually use the loop counter. So here it's a loop. So of course Gatling has to save some information. It has to save the counter somewhere. Actually, in the session as an attribute. If you don't force the name of the attribute, it's a random UID, but you can force it. So for example, you say I. And it's just a session attribute that I can reuse. Here I am. Okay? On the last part, so this is a form. I'm supposed to make things dynamic too. So all my users create new entries in my database and don't insert the same thing over and over again. So I will typically use a feeder there or use something to generate some random data. It's very easy. What I want to show you is how I can implement retry. Retry is, for example, if you have some feigning login, users will keep on trying and trying over again before actually giving up, and sometimes it will just crash your system. So what I want to do is here show you how we can implement retry with Gatling. So this is the form, this is the past. Let's see 1 second. So I'm going to say I want to try this at max twice. And I'm going to make this request artificially fail. So I'm going to add a check on the status. I'm going to say, instead of checking that it's the status is a static value of 200, I want something dynamic. So instead of passing a hard-coded value, I'm going to pass a function that takes the virtual user data as input. And instead of returning 200, I'm going to randomly, third local random. Yeah, there's a bug in Scala ID. Yeah, I want this one. Yeah, this is the bug. Third local random, that current, that next int, 0 to 2. So this will return either 200 or 201. Let's try to run this. So I'm going to run my engine. Come on. Oh, that's because of the network, I think. Come on. Just actually waiting for a timeout. Yeah, here it is. So now I'll have this scenario running. And you see that every second in the console I have some information, some statistics. Is there something weird? Did I forgot to change some think time? There's something bad in here. Oh man. Yeah, problem of live demo. I'm going to show you what kind of sample you can have, what the report would look like. Come on. Yeah. So with Gatling, you get some nice HTML reports with tons of statistics. So here you can see all the requests that are being sent in the simulation with tons of statistics, and typically some percentiles that you want to look at. And you probably want to sort them to find out which requests were the slowest and which one you want to investigate. You can also see the errors that you could get, like here you can see the request that I made artificially fail. You can see how were distributed all your virtual users that were running over time. Some response time distribution, so you can figure out where your actual peak are and figure out, oh, I might have a bottleneck somewhere. Here you can see how your percentiles are distributed. And you can zoom in on a particular percentile and to find out the proper value. And you can zoom in on a given, on a particular request to get the statistics for this particular request. So yeah. So I hope you enjoyed this presentation. Feel free to give Gatling a try. The code is on GitHub. I'm going back to my talk. Yeah. So the code is on GitHub. We have a Twitter account if you want to follow us and get the latest news. Yeah, so feel free to have a look at the code. Feel free to ask some question on our Google group. And, well, give it a try. That was a talk. Make your own opinion about the tool. OK? Do you have any questions? Thank you. Yeah. First one behind you. Yeah. Sorry. Yeah, there's two ways of doing this. You can, for example, capture, instead of capturing one single value, you can say, I want all the values that match a given criteria, like some CSS sectors or something like this. And then, so either you can filter out and select one random entry before saving, actually saving. So you can do that in the check, or later you can save the whole sequence, the whole bag of values, and then with for example, with the Gatling expression language, we have a random function for selecting one random entry in a sequence. Yeah. Sorry. So you can do that manually. You just add some deploy Gatling on several machines and run them all together. And you can, for example, you can collect all the data, or all actually Gatling generates some TSV log file and then generate the reports out of them. But you can just collect the files, put them inside the same directory, and generate the reports out of all the files. Or you can push the data live to something like Graphite, and we're also working on a commercial product on top of the open source one that will also have native support for clustering. Excuse me, I think you had a question. No? Sorry. Yeah, because Gatling also comes, so you can either, so if you have created a Gatling project with Maven, you can launch Maven from the command line, or you can also use the bundle distribution that comes with some launch scripts for Linux and for Windows. Yeah. Yeah, some users actually use Gatling for for functional testing APIs, and sometimes only use it for load testing APIs. Gatling has a nice JSON support, and it's very convenient for testing web APIs. So you can reuse your load test tool, your load test scripts to actually perform also functional tests. SOAP is actually as long as you only use basic things and you don't go with a complex thing like encryption and with a web service security, and you just keep using basic stuff like actually just sending an XML payload over regular HTTP or HTTPS, it's just regular HTTP. So we don't have specific support for SOAP for advanced web service security stuff. But if you're just actually sending a payload over HTTP, it's just plain HTTP actually. Just don't forget the specific headers and things like this, like SOAP action. Another question? Very good. Thank you very much.